రాకెట్ సైన్స్ చూడు ఎంతమంది వచ్చారో. Good morning, my dear students. Today our class is Cerebral Hemispheres. It is a repetition class. Already I told you in CNS. Now it is a repetition class. Cerebral hemispheres, there are two in number. One is right cerebral hemisphere and left. So it is usually a single one, but it is right half and left half. These two are connected in the center by means of thick band of fibers. They are called corpus callosum. They are called corpus callosum. So the cerebral cortex contains outer and inner layers. Outer gray matter, inner white matter. As usual in CNS, gray matter is mainly composed of neurons. White matter is mainly composed of fibers of the neurons. They are axon fibers and dendrite fibers. They are white band of fibers. They are called white matter. So majority of the white matter consists of fibers. So gray matter consists of neurons. We can take it as a graph. Now the cerebral hemispheres, it is called as highest brain. Highest brain. It is a large mass. It is a large mass present in the cavity of the skull. Present in the cavity of the skull. The skull is made up of bones and it provides protection to the inner brain. Present in the cavity of the skull. Now, the large amount of cerebrum, cerebral hemispheres, otherwise called as cerebrum, in a limited space that makes the cerebral hemispheres to folded itself. Sulci and gyri. Sulci are nothing but clefts, and gyri are nothing but elevations. So this is sulci and gyri. So the sulci and gyri pattern of the cerebral hemisphere is called gyrocerebrum. Gyrocerebrum. So if there is no sulci and gyri, if the brain is cerebral hemispheres are plain, or sulci and gyri are not prominent, that is called lissocerebrum. That is called lissocerebrum. So this most prominent part of sulci and gyri, most prominently sulci and gyri presenting, brains of higher animals, human beings and mammals. Human beings and mammals. Whereas in lower animals like reptiles, birds, fishes and etc., this sulci and gyri pattern of cerebral hemispheres is not prominently present in these animals. So the sulci and gyri, so gyrocerebrum is an advanced animal brain. So by observing the more prominent sulci and gyri, you can say it is an advanced animal, especially mammals. Especially mammals. It is the characteristic feature. So if a brain is given to you as a doctor, if anybody asks you what type of brain, cerebrum it is, you can easily tell it by identifying the sulci and gyri pattern. So it is most useful for a pathologist in autopsy examination and also for a forensic doctor. If a brain substance is given and ask the doctor whether it is human or whether it is an higher animals, like that the sulci and gyri pattern is more prominent. Because of evolution in mammals, the brain is very well developed and the sulci and gyri pattern is more prominent. Because of the sulci and gyri pattern, folding nature of the cerebrum, so more amount of brain substance is folded, present in a limited space, cranial cavity. Either cranial cavity. In a limited space, cranial cavity. Now, after end of this session, as a student, You must be able to describe the external features of cerebral hemisphere. Describe the functional areas of cerebral hemisphere. There are so many functions: motor functions, sensory functions, auditory functions, visual functions. So everything is there. So for each function, there is an area present in the cerebral hemisphere. So you have to identify the functional areas where function of these things: audition, hearing, vision, and etc., motor functions, sensory functions. They are controlled by a particular area in the cerebral hemisphere. So you must be able to identify the functional areas. You must be able to describe the functional areas of cerebral hemisphere. And you must be able to give the anatomical basis of motor and sensory aphasias. Aphasia means aphasia, loss of voice. Describe the cerebral hemispheric dominance and discuss its clinical significance, because there are right cerebral hemisphere right off, left cerebral hemisphere left off. So which cerebral hemisphere is dominant in individuals? In some right cerebral hemisphere is dominant, in some left cerebral hemisphere is dominant, in some both are in a balanced manner. So you have to recollect your right coronary artery dominance, left coronary artery dominance, and co-dominance of both right and left coronary arteries balances blood supply to the heart. So their dominance you have studied. I told you in coronary circulation to the heart. So that dominance I have also explained you, and also I explained you which artery arising from the right coronary artery. What artery arising from the right coronary artery decides right coronary dominance? What artery arising from the left coronary artery deciding the left coronary dominance? I have explained you. So what artery supplying the STA node? That is right coronary AV node. That is dominance is decided. So you have to recollect it because it is not the class of circulation of heart. So you have to identify all these things at the end of this session. Cerebrum is the largest part of brain. Two halves called cerebral hemisphere. Ovoid shape of mass, broader behind than anterior. So anterior. So if anybody gives you the brain of human brain, so what is anterior part? So ovoid shape of mass, broader behind than the anterior. That means anterior part is pointed. Frontal region is more pointed. Frontal region of the brain is more pointed than the occipital region. A deep median cleft longitudinal cerebral fissure incompletely separates the two cerebral hemispheres. That means right cerebral hemisphere and left cerebral hemisphere are connected with each other by means of corpus callosum. So it is not a complete separation. So partly a cleft is there dividing the right half and left half. Now, external features of cerebral hemisphere: holes, surfaces, borders, sulci, gyre. Holes, surfaces, borders, sulci, and gyre. Holes: frontal pole, occipital pole, temporal pole. Surfaces: medial surface, lateral surface. Anterior surface, posterior surface. In medial surface, medial supromedial border, intromedial border. In lateral surface, suprolateral surface, introlateral surface. In front area, this is ciliary arch. So ciliary border. So occipital. So that is posterior inferior, anterior inferior. Like that, you have to divide the surfaces and borders, and sulci and gyre. So which sulci and which gyre. Now this is the frontal lobe, central sulcus, 1 centimeter behind the midpoint between the frontal pole and the occipital pole. It is 1 centimeter behind it. This is the occipital pole, more pointed. Anterior part is more broader. This is more wider, frontal pole. So 1 centimeter behind the central point, that is central sulcus, dividing the frontal pole and parietal. The parieto-occipital sulcus and an imaginary line extending from the parieto-occipital sulcus to the pre-occipital lobe, pre-occipital notch, separates the occipital lobe from the parietal lobe above and temporal lobe below. Now the parietal lobe, this is above and this is the below. So this is the parieto-occipital sulcus. This is the pre-occipital notch. An imaginary line. This is because imaginary line. That's why he has represented in a dotted manner, but not in a continuous manner. So this is the first imaginary line. So separating this occipital lobe from the parietal lobe above and temporal lobe below. And the second imaginary line, this is the second imaginary line separating the parietal lobe above and temporal lobe below. Now this is the lateral sulcus. This lateral sulcus extends below the frontal lobe and temporal lobe. It's a deep cleft. It is the most prominent and deep fissure. So lateral sulcus is the most prominent and deep fissure in the cerebrum, extending backwards. So separating the frontal lobe from the temporal lobe inferior. So this posterior ramus, this is anterior part of the lateral sulcus. This posterior ramus of the lateral sulcus, posterior part of the lateral sulcus, and an imaginary line, second imaginary line connecting from here to here, separates the parietal lobe from above and temporal lobe below. So this is the temporal pole. This is the frontal pole. This is the occipital pole. So this is the central sulcus. And 1 centimeter behind the midway between the frontal pole and the occipital pole. So this is central sulcus. So the central sulcus is a more important sulcus, and depending upon the position and distance from the central sulcus, the remaining sulci and gyri are named. So that is the importance of central sulcus. So central sulcus is more important in autopsy examinations, in pathological autopsies, because if you identify the central sulcus, you can name the remaining sulci and gyri. So central sulcus is the more important sulcus that is useful in pathological autopsy examination. Central sulcus is 1 centimeter behind the midway between the frontal pole and the occipital pole. So you must know the important sulci and important gyri in functional areas. So that is important. Now poles, each hemisphere presents 3 poles: frontal, occipital, temporal. Surfaces: supralateral, medial, inferior surfaces. Border: supramedial border, superciliary, introlateral, medial, inframedial, and hippocampal, and medial occipital border. So I have already explained you without the PowerPoint in the lecture. So you have to see it in the PowerPoint once again. Now sulci and gyri. Cerebral hemispheres become folded, producing numerous convolutions separated by fissures. Convoluted cerebral cortex is termed gyrencephalic. Sulci depth varies. So all sulci are not similar in depth and similar in shape. They differ. For example, lateral sulcus is more deep when compared with the other sulci present, remaining sulci present in the brain. Gyri consists of central core of white matter covered by a layer of gray matter, the cerebral cortex. So sulci means deep fissures. Gyri means in between the two sulci, adjacent sulci, that is the gyri. Gyri is nothing but a central core of white matter covered by the layer of gray matter, the cerebral cortex. The outer part of the cerebral hemisphere is gray matter. Inner part is white matter. Now important sulci and gyri. Lateral sulcus, central sulcus, parieto-occipital sulcus, and calcareous sulcus. Already I show you lateral sulcus, central sulcus, and parieto-occipital sulcus. This calcareous sulcus is present on the medial side of the cerebral hemisphere, posterior to the splenium of the corpus callosum. That is a point. When you explain a calcareous sulcus, you must write a single point. Calcareous sulcus is present on the medial surface of the cerebral hemisphere, posterior to the splenium of the corpus callosum. I will show you. You have to write that. Now this is the calcarean sulcus. This is the corpus callosum connecting the right cerebral hemisphere and left cerebral hemisphere. Now this is the calcarean sulcus. This is the splenium of the corpus callosum. So extending backwards in a convex manner and is the calcarean sulcus. So parieto-occipital sulcus is connecting the calcarean sulcus to the this one. So this is calcarean sulcus. This is calcarean sulcus. So the area present between the parieto-occipital sulcus above and posterior part of the calcarean sulcus is called cuneus. Where I pointed, that is cuneus. So the area prior to the cuneus is called precuneus. Now this is the corpus callosum. This is the splenium of the corpus callosum. So a sulcus is present above the splenium. It is called suprasplenial sulcus. This is suprasplenial sulcus. Now this is called, this area is called, this is the cuneus. It is present between the parieto-occipital sulcus and posterior part of the calcarean sulcus. So this is cuneus. So this is precuneus because it is prior to the cuneus. It is called precuneus, like that. Now this is the corpus callosum. This is the corpus callosum. This is the corpus callosum. It is nothing but a white band of fibers connecting the right cerebral hemisphere and left cerebral hemisphere. So a sulcus is present above the corpus callosum. That is called callosal sulcus. This is called callosal sulcus. This is called callosal sulcus. So this is the corpus callosum. This is a sulcus is present between this brain substance and the corpus callosum. That is called callosal sulcus. So immediately above the corpus callosum, in line with the corpus callosum. This is in line with the corpus callosum. That is called cingulate sulcus. So the area present between the callosal sulcus and cingulate sulcus is called cingulate gyrus. This is called cingulate sulcus. This is called callosal sulcus. This is called cingulate sulcus. So the area present between the callosal sulcus and the cingulate sulcus is called cingulate gyrus. This is called cingulate gyrus. This is the frontal lobe. So this is the entire medial aspect of the cerebral hemisphere, whether it may be right or left. So this is called medial frontal gyrus. This is medial frontal gyrus. This is medial frontal gyrus. So like that, depending upon. This is the temporal lobe. It has got this one and this one. Now this one is a sulcus. This one is a sulcus. So these two sulci, this is the rhinal sulcus and this is the occipitotemporal sulcus, because this is the occipital pole, this is the temporal pole. So this is occipitotemporal sulcus. Occipitotemporal sulcus 1, and this is the rhinal sulcus, 2 sulci dividing the temporal lobe into 1 gyrus, 2 gyrus and 3 gyrus. So this is lateral occipitotemporal gyrus. So this is the above one is middle occipitotemporal gyrus, and this is superior occipitotemporal gyrus. So this is lateral occipitotemporal gyrus. This is middle occipitotemporal gyrus. This is superior occipitotemporal gyrus. So like that we have to name here. This is lateral occipitotemporal gyrus. This is middle occipitotemporal gyrus. This is superior occipitotemporal gyrus. Now an area immediately above the calcarean sulcus and below the splenium of the corpus callosum is called isthmus. This area is called isthmus. This area is called isthmus. And a projection of temporal lobe on medial side, a rounded projection into the base of the brain, into the base of the brain. This is the corpus callosum. This is the this one, this ventricle. You have to identify it. So you must be able to know. This is called uncus. This is called uncus. So like that, you have to identify a sulcus and gyri. Important sulci and gyri, I told you. So you have to see the diagram. It is present in your standard textbook. Corpus callosum, cingulate sulcus, cingulate gyrus, I show you. Important lobe, superior and inferior temporal sulcus, superior, middle and inferior temporal gyrus. I already explained you. Anterior temporal gyrus or results gyrus forms the primary auditory area of cortex. So each, why this brain is divided by sulci and gyri, you must know the full-fledged knowledge of important sulci and gyri, because you have to mention the area, functional area, which is present in which part of the gyrus. Yes, given. Anterior temporal gyrus or Hazel's gyrus forms the primary auditory area of the cortex. So, sulci and gyri are the medial surface. In general, I have explained you. This is the medial surface diagram. So, you have to see parieto-terminal, para-olfactory gyri, anterior and posterior para-olfactory sulci, callosal sulci, paracentral lobule, medial frontal gyrus, everything is given in the diagram. Now, paracentral lobule is the cortical highest center of the mixation and defecation. Paracentral lobule is the cortical highest central of mixation and defecation. Calcaneal sulcus, parieto-occipital sulcus, I had told you cuneus and precuneus. I will explain you where is cuneus. This is cuneus, this is precuneus. This is central sulcus or medial aspect. Now this is one area and this is one area. This is motor area, this is sensory area. So the area in front of the motor area is premotor area. The area behind the sensory area is called presensory area. So central sulcus is taken as a measurement. So this is motor area, this is premotor area. This is sensory area and presensory area. So primary sensory area, secondary sensory area. Primary motor area, secondary motor area. Are you able to follow it? This is the central sulcus. This is motor area. This is secondary motor area. This is sensory area. This is secondary sensory area. Like that, you have to divide the areas. Now, sulci and gyri present on the inferior aspect, on the tentorial part. Medial one is collateral sulcus, lateral one is occipitotemporal sulci. Again, two sulci is there. They divide the tentorial surface of the tentorial part of the brain, that is inferior surface of the brain, into two sulci divided. So, this is occipitotemporal sulcus. This is collateral sulcus. How they are divided? Parahippocampal gyrus, medial occipitotemporal gyrus, lateral occipitotemporal gyrus. Because hippocampus area is present here, that's why it is called parahippocampal gyrus. Hippocampal area is present in this one. This one, the gyrus is called parahippocampal gyrus. So this is extension of calcaneal sulcus on the medial side. So between the calcaneal sulcus and the collateral sulcus or posterior aspect towards the occipital region is called lingual gyrus. Lingual gyrus. This is called lingual gyrus. If you carefully sit down and carefully study and carefully follow, you can easily identify. Now this is the inferior surface of the frontal pore. So an H shape is there. This is called orbital sulci. This is anterior area of the orbital sulci. Anterior to the orbital sulcus. This is posterior. This is called P. This is medial. This is lateral. So this is the orbital sulcus, H-shaped orbital sulcus. So now this is the olfactory nerve and olfactory bulb. So the central part is called olfactory sulcus. This is called olfactory sulcus. This is olfactory bulb. So this is olfactory bulb. And olfactory sulcus is a cleft present on either side of it. This is a gyri. This area is called olfactory area. Now, this is optic chiasma. So you have to see the diagram repeatedly and study the book. You have to see the diagram repeatedly and see the PowerPoint. You can easily identify the functional areas of the cerebral hemisphere because it is a repetition class. Cerebral cortex is the surface layer of gray matter covering the cerebral hemisphere. Cerebral hemisphere controls the opposite half of the body, sends motor commands to the received sensory information from opposite half, contralateral. Cerebral hemisphere controls the opposite half of the body, sends motor commands to the received sensory information from opposite half, contralateral. So, right cerebral hemisphere controls left part of the body, left cerebral hemisphere controls right part of the body. It is contralateral function. Types of cerebral cortex. Oldest cortex, archicortex. In man, hippocampus and parts of the right and cephalic region are old cortex. Paleocortex, intermediate in development, cingulate gyrus. Neocortex, this is modern cortex. Recent in development, 90% of the total area of cerebral cortex is modern cortex. So, depending upon the embryological development, so newly developed 90%, that is neocortex. Paleocortex, intermediate in development, cingulate gyrus. Oldest archicortex in man, hippocampus and parts of rhinocephalic region. So, again, cortex is divided into modern, intermediate, and old. So, which part of the brain, cerebral cortex is involved in older development, old functions. Paleocortex, intermediate in development. So, neocortex, modern in development. So, the cerebral cortex is divided. So, you have to identify which area the cerebral cortex is younger, or neocortex, which area the cerebral cortex is paleocortex, which area the cerebral cortex is archicortex. Already I mentioned in PowerPoint, hippocampus and part of hydrocephalic region are oldest part of the archicortex. So, I will show you. This is hippocampal area, this is oldest. Cingulate gyrus. You see, cingulate gyrus. Where is cingulate gyrus? This is intermediate in development. So, remaining part is 90% is recent in development. So, remaining total area of the cerebral cortex is modern here. So, only a few part, only a limited part is intermediate and neocortex. So, you have to, I have explained you in the PowerPoint, I have shown you in the diagram. There is older cortex, there is intermediate cortex, there is modern cortex. So, if a brain is given to you, if an examiner asks you to identify the neocortex, you have to show the entire area. If the examiner asks you intermediate development, the paleocortex, you have to show the cingulate gyrus. If the examiner asks you oldest archicortex in man, hippocampus and parts of the rhinocephalic region. So, we have to show the. So, which part of the brain is older, which part of the brain is intermediate in development, which part is newer in development, recent in development. So, area of the cerebral cortex. Like that, you have to divide the area. Structure of cerebral cortex comprises nerve cells, synapses, neuroglia, 14,000 million of neurons. Types of neuron, pyramidal cells, stellate or granular cells, horizontal cells of Kajalu, cells of Martinotti, fusiform cells. So, neuron is the structural and functional unit of the central nervous system. So, whatever the neurons present in the brain, all are these pyramidal cells, stellate or granule cells, horizontal cells of Kajal, cells of Martinotti, and fusiform cell. So, you have to write, there are 14,000 millions of neurons present, cell comprises nerve cells, synapses, and neuroglia, 14,000 millions of neurons. All the neurons are divided into 5 groups: pyramidal cells, stellate cells, granule cells, horizontal cells of Kajal, cells of Martinotti, and fusiform cells. Depending on the function, motor neuron, sensory neuron. 5 main types of neurons in cerebral cortex. This is the diagram. Pyramidal cells, horizontal cells, cells of Martinotti, stellate cells, fusiform cell. 1, 2, 3, 4, 5. Layers of cerebral cortex: molecular, plexiform layer, external granular layer, external pyramidal layer, internal granular layer, internal pyramidal or ganglionic layer, multiform layer, layer of polymorph cells. 1, 2, 3, 4, 5, 6. So layers of cerebral cortex. So 5 types of neurons are there and 6 layers of cerebral cortex. So cerebral cortex consists of 6 layers. Now, this is the diagrammatic representation of 6 layers: plexiform or molecular layer, external granular layer, they are densely packed, external pyramidal layer, small and medium sized pyramidal cells, how they are pyramidal cells, internal granular layer, closely packed stellate cells, outer band of Brelgari. You see, this is external granular layer, this is internal granular layer. So, the difference, external granular layer. This is external pyramidal layer, small and medium sized pyramidal cells. Internal pyramidal layer are ganglionic layer. Large pyramidal cells serves a bed and inner band of Brailer layer. Now, multiform polymorph layer, cells of multiforms merge with white matter. So, this is the 6 layers: 1, 2, 3, 4, 5, and 6. 6 layers of cerebral cortex. 5 types of neurons. Variations in the cortical structure, both in terms of thickness and prominence of various layers. Homotypical, heterotypical. Heterotypical again, granular, agranular. Homotypical means entire thing is same. Heterotypical means different things are present. So in different things, granular, agranular. Thickness and prominence of various layers. Functional areas in cerebral cortex divided into a large number of functional areas. Brodmann divided into 47 areas. This is called as Brodmann's classification. Motor area, it has got numbers. Sensory areas, it has got numbers. Association areas, it has got numbers. All numbers falls within 47 only, but not beyond 47. Now this is the central sulcus. This is primary motor area, area number 4. This is premotor area 6. This is primary somatosensory area 231. This is area 5. This is area 7. 40. Sensory speech area of Vernix, this area. 22, secondary auditory area. So, primary auditory area is this one, 41 and 42. 22 is secondary sensory area. Now, this is motor speech area of Broca, 44 and 45. So, this is the occipital pole. This is the parieto-occipital sulcus. This is the pre-occipital notch. And imaginarily connected. This is the primary visual area. This is visual association area. So, visual area is present in occipital lobe. Auditory area is present in temporal region. Sensory speech area is present here. Now, this is motor speech area of Broca. This is present in frontal lobe. This is the area. So, which area is present in which part of the cerebral cortex? What number? He has given a number to them. That is the reason. Functional areas in frontal lobe. Primary motor area, area 4 of Brodmann. 47% of pyramidal fibers arise from this area. Human body is represented upside down in the precentral gyrus inverted homonucleus. Clinical correlation. Lesions of primary motor area in one hemisphere produce flaccid parallels of opposite half of the body, hemiplegia. This is frontal pole, this is prefrontal area. How he has given areas numbers. Ankas, primary olfactory area 28. This is para-hippocampal gyrus. oldest area of the brain in development. How they are inverted positions, motor and sensory homonucleus. So, the representation of human body parts in area wise in the central nervous system does not depend upon the mass. It depends upon the skillness. For example, upper limb, which is more skilled, has got more functional area in the brain when compared with lower limb, which has not much skilled movements like upper limb. So, depending upon the skillness of the function, more area is represented. If the skillness of the function is important and more skillful movements are there, more skillful functions are there, that area is represented largely in the brain when compared with functions not associated with skill, mass functions. Premotor area is the main site for cortical organ of extracerebral, cortico-rubral, cortico-alveolar, cortico-regular fiber. Clinical correlation. Lesions of premotor, secondary motor area produce difficulty in the performance of skilled movements. Supplementary motor area, MS level, located in the medial frontal gyrus on the medial surface of the hemisphere, because what type of function is present in a particular area that was given a name that is identified depending upon the sulcus, depending upon the guide. Clinical correlation. Lesions of supplementary motor area produce bilateral flexor hypotonia. Hypotonia, tone means muscle tone. Flexor hypotonia. Flexor tone of the muscle is reduced hypo, below the level, with no paresis. There is no paralysis or paralysis. There is no paresis. Paralysis means complete. Paresis means partly. Paralysis means complete loss of function. Paresis means partly loss of function, that is called paresis. That is the difference between paresis and paralysis. Paralysis means complete. Paresis means to certain extent, that is called paresis. Frontal eye field area, area 8, posterior part of the middle frontal gyrus, located in posterior part of middle frontal gyrus. The frontal eye field controls voluntary scanning movements of the eyes and is independent of the visual stimuli. So, MS1 and MS2. Motor speech area of Broca's 44 and 45. Located in pars triangularis area 45 and pars ocularis area 44 of the inferior frontal gyrus of frontal lobe in left hemisphere, right hand people. Clinical correlation. Lesions of this area produce loss of ability to speech, expressive aphasia, motor aphasias. So I had mentioned which area. Already I had named the areas. So which area is associated with damage of that particular area is associated with the loss of certain functions. That is clinical correlation. So you have to read it very well because it is more important. You are in general medicine and also your clinical practice. You want to become a DM neurology or MCH neurology. This knowledge is more than enough. You must know it very well. Prefrontal area, frontal lobe, rostral to motor and premotor area, concerned with individual personality. It is concerned with depth of emotions, social, moral, and ethical awareness, concentration, orientation, and foresightedness. Bilateral destruction of frontal area due to trauma results in profound change in personality. Functional areas in the parietal lobe. Parietal lobe. Ante functional areas in the frontal lobe, functional areas in the temporal lobe, functional areas in the parietal lobe. 4 lobes. There is a hidden lobe also, that is 5th lobe, that is insula. Hidden lobe, that is called 5th lobe. So basically majority 4, and a 5th lobe is also there in the cerebral hemisphere, that is hidden lobe, that is called insula. It is nothing but a mass of temporal lobe dipped inside. Lesions of primary sensory area lead to loss of appreciation of exteroceptive and proprioceptive sensations from opposite half of the body. Secondary sensory area, small, is located in upper lip of the posterior rams of the lateral sulcus. The whole body is represented bilaterally. This area relates more to pain perception. Ablation of this area may relieve intractable pain. Sensory association area occupies the superior parietal lobule, corresponds to the area 5 and 7. It is concerned with the perception of shape, size, roughness, and texture of the objects. Clinical anatomy. Lesion of this area results in inability to recognize or identify an object by its feel. This condition is called tactile agnosia or stereogenesis. That means if you give a coin, you cannot identify the coin if kept in the hand. The patient don't know what is it. It is nothing but tactile agnosia. Stereognosis by feel. You give a coin, he cannot say coin. If you keep a coin in his hand, you ask him to say, what is that? He cannot say, it is a coin. Sensory speech area of learning. It is located in the left dominant hemisphere, posterior part of the superior temporal gyrus area 39 and 40. It is concerned with the interpretation of language through visual and auditory input. Sensory and motor speech areas exist together in one hemisphere only. Loss of Benwick's area in the dominant hemisphere produces loss of ability to understand spoken and written speech. This condition is called receptive sensory aphasia. So already brain is divided by sulci into gyri. Is divided into 4 lobes: frontal lobe, occipital lobe, parietal lobe, and temporal lobe. A 5th lobe, insula, is also present. So sulci, gyri are present in the in lobes. So the areas of the brain, cerebral hemisphere, are named by Brodmann into 47 areas. So which area is associated with which function, and damage of that area is associated with the loss of function. That is the written in the PowerPoint. That is, I am telling you, you have to follow it, you have to identify it. So this is the functional areas and temporal lobe, clinical anatomy. So difference between motor aphasia and sensory aphasia. Secondary auditory area 22, clinical correlation. So the same is given. Functional areas in the occipital lobe, visual area, temporal lobe, auditory area. Secondary visual area, visual association area. Primary motor area, secondary motor area. Primary sensory area, secondary sensory area, or sensory association area. So visual area or visual association area. That is clinical correlation. Other functional areas in cerebral cortex: taste area, gustatory area, located in the inferior part of parietal lobe, adjoining area of insula, area 43. Vestibular area is probably located near that part of the postcentral gyrus, which is concerned with the sensational phase. Olfactory area, Brodmann's area 28, is located in the anterior part of the parahippocampal gyrus. So this is the naming for the sulci and gyrus. Cerebral hemisphere dominance. Congruity in size, shape, features are same for right and left cerebral hemisphere. There is no difference in weight. There is no difference in shape of the right cerebral hemisphere and left cerebral hemisphere. Both are same. But neuronal activities, they are not mirror images. They are not mirror images. Each hemisphere has its own contribution. Each hemisphere has its own contribution. Left hemisphere is more efficient as far as handedness perceptions, perception of language, speech, writing calculations, numerical skills are concerned. So left hemisphere is more efficient in doing these functions, language, speech, writing calculations, numerical skills. So right hemisphere is more efficient with spatial perception, recognition of faces, creative acts of arts and music, and non-verbal ideation. If anybody who is more artistic in nature, he says, we can say that right cerebral hemisphere is more dominant. This is the dominance. The term dominant hemisphere is referred to side concerned with the perception and production of language, speech. 90% left hemisphere dominant, right-handed person. So depending upon our hand dominance, you are a right-handed person, you are writing with right hand, then left cerebral hemisphere is more dominant. So if you write with right hand, right-handed people, their left cerebral hemisphere is dominant. Left hand writing people,
Right cerebral hemisphere is more dominant. After first decade, only dominance becomes fixed. Up to the 10th year, the dominance is not fixed, but it is genetically decided. So after that only, it will be fixed. During that time, both will function. So that is the dominance. Thank you very much. It is a repetition class. You must know it very well.